Well, this is John White, Breaking Mad, here to talk about how to get hexamine. What is hexamine? That's basically used in solid fuel tablets, like for campers. If you watch my How to Get Trioxane video, you'll know it's basically the same thing. And that's why you have to, like I said, when you buy trioxane, same thing with this. When you buy it, look up the MSDS and make sure that there's no trioxane in there. Because a lot of companies will put both in. You know what I mean? Now, I looked up three MSDSs. One was Thermo Fisher Scientific. You can see it has a greater than 95% of hexamine. Uh, what the other impurities are, it didn't say. I looked up another one that I didn't mark down here because it was just crap. It was like 60 to 100% hexamine, so I didn't even write it down. But the best one, I only looked up three. So this third one is, as you'll see at the bottom there, Expedition Fuel Tablets, hexamine solid camping fuel. Now that is less than 99% hexamine and less than 1% wax, and that's by weight, percentage weight. So you don't know exactly how much, but you can assume it's probably 98, 99% hexamine. Um, if it, you know what I mean, usually when the impurity is so small that they don't write it down, that means there isn't much impurity in there. It's just, you know what I mean, half a percent of this, a half a percent of that. I don't know. I'm just saying there's some examples where you can almost, I mean, 99% hexamine, that's pretty good. All right, so where can you get some hexamine? Anywhere they sell camping supplies, like a survival store, a camping store like Dick's, Walmart, eBay, Amazon, maybe even some hardware stores like Lowe's. I don't know about that, but they might even have them in Lowe's and hardware stores. That's just to name a couple. So here's a picture of hexamine, 280C. It sublimes in a vacuum. Um, Now I want you to look at how you make this. You'd have 6 moles of formaldehyde, 4 moles of ammonia, and you'd make some hexamine and some water. But I also want you to look at how you make methylamine. Okay, this is actually the formula down here: 2 formaldehydes for every mole of ammonium chloride. And you would make this. You'd make your methylammonium chloride, or if you want to call it methylamine hydrochloride, and you would also make formic acid. Right? You got 2 carbons here. One would split up and keep this carbonyl and be oxidized to that, and the other one would connect to the NH2 of this. Right? Now, what happens when you do this reaction is you make this stuff. This is actually more reactive than the ammonium chloride. So it will start attacking you know what I mean? The reaction will start being between the formaldehyde and this instead of the formaldehyde and this, right? So what you do is you want to add in excess ammonium chloride. This will cut down, adding excess will cut down on the formation of dimethylamine, okay? And I want you to look up here. This is the excess you'd want to use. If you had, um, if you had 6 uh, moles here, then the ratio is 2 to 1, so you'd want 3 moles here, but the excess would be this extra mole. So a 6 to 4 ratio, molar ratio, is almost, it's not exact, but it's almost exactly what you want. You know what I'm saying? Now I want you to compare it with this and this. 6 formaldehydes, 6 formaldehydes. 4 ammonias, 4 ammonium chlorides, right? The chloride salt of ammonia. Now I want you to look at this. Now I don't know if this formula is correct or not, or whatever. This is guesses here now. But look at what happens when you take hexamine and you hydrolyze it, which that's a fact. You can hydrolyze it with HCl, right? I put 4 moles. That's the guess. But you would break this down into, and you just need a catalyst. I don't think you need 4 moles to break it down, right? But you add in your HCl, you just need a little bit of it to catalyze this reaction, right? I think, I'm not sure. But you'd break it down into its constituents, which would be 6 formaldehydes and 4 ammonias. Now, since I put in 4 moles of HCl and there's 4 moles of ammonia, right? They react to make to make ammonium chloride, 4 moles of ammonium chloride, right? So you see what I'm saying? If you add the HCl to this, it breaks it down into the exact ratio and components that you want to make methylamine, right? Now remember, when you're doing the reaction of making methylamine, you're going to make your methylamine salt, right? The hydrogen chloride salt. You're also going to make formic acid, right? Now, if you freebase that, okay, let's say you get down in your major methylamine and you got formic acid in there, how are you going to get it out? So you add some sodium hydroxide. What will happen is this salt, right, of your methylamine will become just methylamine without the salt. This, this will turn into sodium formate, right? So now you switch it over. Remember, the methylamine used to be a salt. Now it's not a salt. The formic acid used to be an acid. Now it's a salt. See how so you can easily separate it. Salts are soluble in nonpolar solvents. You know what I mean? So you freebase it. This you can soak up into benzene or some kind of nonpolar solvent. This will go into the polar water, and you can easily separate it. So like I said, I never done this reaction, but full modern alchemist did. He's actually the only one I've seen on YouTube that did a video. So I'm going to put a link to the description down below this video so you can go check his video out. And then sooner or later I will make a video where I do this and talk about this reaction, how I would do it step by step. And then I will also do a video where I actually do it step by step, you know what I mean, and do the reaction, not just talk about it. Now this hexamine has other uses. Now I'm not going to go over every reaction this thing can do because there's a lot of them, but I'll go over 3 more. One, real quick, the Duff reaction. You're basically taking a benzene ring and you're adding on a formal group so that you can make a benzaldehyde derivative. The reason why this works is because you have to have an electron donating group attached to the ring in the first place. That activates this ring, right? If it's electron donating, it's donating electrons into this already electron-rich pi, resonance thing here. It activates this, you know what I mean? It makes it more negative, more electron density. Keep in mind, you probably need a strong electron withdrawing group. You can't just have an alkyl group on there. At least that's my guess. So you mix that with the hexamine, and you're going to add your formal group. It's going to go ortho to your electron donating group. And if those two ortho positions are filled, then it will add to the para position. Now you can take the product that you made, right? Your benzaldehyde derivative, put it in with some zinc dust and distill it, basically. And when you distill it, these two will react and benzaldehyde will come out. And that's what you can make from phenol. Phenol hexamine, make your benzaldehyde derivative, boil it in zinc dust, boom, distill out your benzaldehyde. Now that was the Duff reaction. This next one is called the Somlet reaction. Take a benzyl halide like benzyl chloride, benzyl bromide, react it with water and hexamine, do a workup, I guess, of protons, water. You lose some acid here, and you make benzaldehyde and your acid. The acid, if you start out with benzyl chloride, you're going to end up with hydrogen chloride gas. If you end up with benzyl bromide, you're going to end up with hydrobromic. So this is a nice way to make a benzaldehyde from a benzyl halide. Next reaction is the Delpine reaction. It's used to make primary amines. You can take a alkyl or benzyl halide, react it with the hexamine, and make this salt. I'm guessing. Alright, so this is down here. You add, if it adds 3 moles of HCl and 6 waters, you end up making your primary amine, hydrochloride salt, plus 6 formaldehydes and 3 ammonium chlorides. And I want you to think about it. Remember, hexamine consists of 6 formaldehydes and 4 ammonias, right? And if it's an acid, then 4 ammonium chlorides. Look what it has. It has 6 formaldehydes and only 3. What happened to the 4th ammonia or ammonium chloride? It's right up here. It made your amine. It made your primary amine. Now my guess is that the remaining formaldehyde and ammonium chloride that you make doing this Delapine reaction, you're probably going to make methylamine with that. So you're going to have some methylamine. A lot of methylamine is a impurity trying to make your other main primary amine. Of course, that's just a guess, but it looks like it to me. Anyways, I'm not going to get into the, these are just generic, showing you these equations or whatever. But sooner or later I will give exact instructions on how I would do this, and then eventually I will do the actual experiment. So you all have a great day, and always remember, science is great.